Hello, and welcome. You're watching the very first episode of the Exploration Hub. Imagine a world without tools, weapons, cities, or machines. A world where everything humans needed to survive had to be carved from stone or shaped from bone. But one discovery changed everything. Metals. Tough, workable, and often beautiful. Metals were exactly what humans had been searching for, long before we even understood what they were. Today, we're exploring how humans first encountered metals, learned to refine them, created alloys, and how those discoveries quietly reshaped civilization. Part 1. Our first encounter with metals. For most of human history, life revolved around stone and bone. Stone tools, bone weapons, and carved art. Then, something different appeared. Something shiny, heavy, and strangely alive in the hand. Unlike stone, it didn't shatter when struck. It bent. It changed shape. It responded. Our earliest encounters with metal were likely fragments of meteoric iron that fell from the sky. But there is little evidence that early humans worked with meteoric iron extensively. It was extremely rare and difficult to shape. The earliest, clear evidence instead comes from copper. In the 1960s and 1970s, archaeologists excavating Tayonu Tepesi in southeastern Turkey uncovered some of the oldest known proof of humans working metal. Small copper beads and tools dating back to 8,200 to 7,500 BCE. These objects were not made in furnaces. They were crafted from native copper, cold hammered directly from metal found in nature. A remarkable early step toward metallurgy. Early humans may have noticed a strange reddish stone in a riverbed, picked it up, and discovered that instead of breaking, it flattened and stretched when struck. Curiosity did the rest. Beads became ornaments. Ornaments became tools. And almost without realizing it, the age of metals had begun. Copper wasn't the only metal explored during this early period. Humans, likely, worked with gold as well, shaping it into ornaments. Like copper, gold can be formed without furnaces or smelting, simply by hammering naturally occurring metal. These early discoveries marked the first steps in humanity's long relationship with metals, a journey that would soon lead to fire, furnaces, and transformation. Part 2. The first smelting, from hammering to fire. Until now, humans could only shape metals found directly in nature. Native copper, gold, and perhaps iron from fallen stars. But most metal remained hidden inside ordinary-looking stones known as ores. To unlock them, humans needed something new: fire. Smelting is the process of heating metal-rich rock until the metal separates from the stone. Today, it seems simple, but at the time, it was a revolutionary breakthrough. The moment humans stopped collecting metal and began creating it. In 2010, archaeologists working at Belovod and Plochnik in present-day Serbia identified copper slag and furnace, remains dating to 5,500 to 5,000 BCE. Slag, the waste left behind after smelting, proved that copper was being produced intentionally, not simply shaped from natural nuggets. Similar early smelting sites also appear in the Levant, suggesting that metallurgy may have developed independently in more than one place. So how did smelting begin? Most likely through curiosity and accident. A copper-rich stone tossed into a fire. Hours later, something new remains. A bright, malleable substance that behaves like metal. Over generations, humans learned to control heat, build furnaces, and refine the process. Smelting changed everything. For the first time, humans could create metal where none had existed before. And with that, a new age began. Part 3. Humanity's supermaterial. Once copper was mastered, experimentation continued. Gold, bright and soft, was among the earliest metals encountered. Its beauty made it valuable, but its softness limited its use to ritual and symbolism. Silver followed, sometimes found naturally, sometimes extracted from ores through heating. Lead soon joined it, melting easily and finding use in vessels and weights. Then came tin. By itself, tin was unremarkable, but when added to molten copper, it created something extraordinary. Bronze. Bronze was stronger, tougher, and more reliable than copper. For the first time, humans were engineering materials rather than simply using them. This innovation marked the beginning of the Bronze Age, around 3,300 BCE. Archaeological sites like Uruk, Troy, and Alaka-Hoyuk reveal tools, weapons, and workshops dedicated to bronze production. As bronze spread across the ancient world, it transformed trade, warfare, and society itself. Part 4. Iron, the metal humanity. Almost missed bronze dominated the ancient world for centuries, yet beneath the soil lay a metal far more abundant and far more difficult to unlock. Iron. Unlike copper or gold, iron rarely appears in pure form. It is tightly bound within stubborn ores and requires extreme heat to extract. For thousands of years, humans walked past iron-rich stones without realizing what they contained. Once again, the earliest iron objects came from the sky. Meteoric iron was shaped into beads and ceremonial blades, including the famous dagger buried with Tutankhamun. But meteoric iron was rare. It could not support civilizations. True ironworking emerged around 1500 to 1200 BCE. With the development of bloomery furnaces, these produced a spongy mass of iron that had to be hammered repeatedly to remove impurities. It was difficult, unpredictable, but it worked. Once the knowledge spread, iron changed everything. Iron ore was widespread. Tools and weapons could be made locally, in large quantities. Over time, carbon entered the process, giving rise to early steel. Stronger and more durable than bronze, steel ended the Bronze Age forever. Iron reshaped warfare, agriculture, and power. Metal was no longer reserved for elites. It became accessible. Part 5. The Age of Metals. From Earth to Industry. After iron, metal knowledge expanded rapidly. Arsenic, mercury, zinc, brass, and complex alloys followed. By the Industrial Age, metals were no longer isolated materials. They were interconnected systems. Steel enabled scale. Aluminum transformed transportation. Copper carried electricity. Titanium offered strength without weight. Modern life depends on dozens of metals working together. Phones, power grids, vehicles, and spacecraft are all built from carefully selected combinations. What began with a shiny stone in a riverbed became a civilization shaped at the atomic level. Part 6. The Future of Metals. Today, metallurgy is about precision and responsibility. High-entropy alloys, shape memory metals, and superalloys define modern engineering. Recycling has become just as important as mining. Lithium, cobalt, and rare earth metals now power batteries, renewable energy, and electric transportation. Beyond Earth, asteroids rich in metal are being mapped, hinting at a future where metallurgy extends into space. Out of 118 known elements, over 90 are metals. From the first hammered nugget to materials engineered atom by atom, metals have quietly shaped who we are and who we are becoming. And as long as humans continue to build, explore, and imagine, that story is far from finished. So let us leave with one final question. Will the future depend less on metals, or will they remain central to our evolution as a species? Thank you for watching the first episode of the Exploration Hub. If you enjoyed this journey, please like, share, and subscribe for more educational and inspiring stories.